An ancient story tells us about the story of a gold ground and how Archimedes, a Greek mathematician, scientist, engineer, inventor, and astronomer, uses density, which is the second property of material which we will discuss in this video, to prove the dishonesty of a goldsmith.
One day, Archimedes was summoned by the king of Sicily to investigate if he had been cheated by a goldsmith. The king said he had given a goldsmith the exact amount of gold needed to make a crown. However, when the crown was ready, the king suspected that the goldsmith cheated and slipped some silver into the crown, keeping some of the gold for himself. The king asked Archimedes to solve the problem, but there was a catch. He couldn't do any damage to the crown. One day, while taking his bath, Archimedes noticed that the water level in the bathtub rose and overflowed as he immersed himself into the tub. He suddenly realized that how much water was displaced depended on how much of his body was immersed. This discovery excited him so much that he jumped out of the tub and ran through the streets naked, shouting, "Eureka!" which comes from the ancient Greek meaning, "I found it!" What did he find? Well, he found a way to solve the king's problem. You see, Archimedes needed to check the crown's density to see if it was the same as the density of pure gold. Density is a measure of an object's mass divided by its volume. Pure gold is very dense, while silver is less dense. So if there was silver in the crown, it would be less dense than if it were made of pure gold. But no matter what it was made of, the crown would be the same shape, which means the same volume. So if Archimedes could measure the mass of the crown first and then measure its volume, he could find out how dense it was. But it is not easy to measure a crown's volume. It has an irregular shape that's different from a simple box or ball. You can't measure its sides and multiply like you might for other shapes. The solution, Archimedes realized, was to give the crown a bath. By placing it in water and seeing how much water was displaced, he could measure the volume. Then he'd calculate the density of the crown. If the crown was less dense than pure gold, then the goldsmith most definitely cheated the king. When Archimedes went back to the king and did his test, the story says, he found that the goldsmith had indeed cheated the king and slipped some silver in.
As mentioned in the video, one of the properties of solids, as well as liquids and even gases, is the measure of how tightly the material is packed together. That is what we call density. Density, by definition, is a measure of how much matter is squeezed into a given space. In the formula, we can write it as mass per unit volume. What do you think would happen to the density of a chocolate bar when you break it in two? The answer is nothing. Each piece may have half the mass, but each piece also has half the volume. Density is not mass and not volume. Let's take a look of this table of densities in the left. As you can notice, osmium, a hard bluish-white metallic element, is the densest substance on Earth, even though the individual osmium atom is less massive than individual atoms of gold, mercury, lead, and uranium. The closest spacing of osmium crystals gives it the greatest density. One important factor in determining the density of materials is their crystal structure, which you probably remember in our previous discussion. A crystal lattice is represented in terms of unit cells, and unit cells closely packed with one another are most commonly denser. A good example is a comparison of tin and manganese. Tin has atomic number of 50 and atomic weight of 118.7 atomic mass unit, while manganese is number 25 with an atomic number of 54.9 atomic mass unit. However, let us look back in our table. The density of tin is lower at 7.31 gram per cm cube, while the density of manganese is 7.43 grams per cm cube. In other words, even though the mass of manganese atoms are one half that of tin, its density is higher than of tin. The explanation is that although the tin atoms are larger, they are more spread apart than the smaller manganese atoms. One result of the tin atoms having more separation is that tin is softer, while the closely packed manganese is hard and brittle. One of the most common uses of density is in how different materials interact when mixed together. Wood floats in water because it has a lower density, while an anchor sinks because metal has a higher density. Helium balloons, the density of the helium is lower than the density of air. Density is also an important consideration in many professions. For example, engineer needs to understand the concept of density if he is planning to build anything where weight and distribution of weight is critical. The building of ships and aircrafts are two instances where density comes into play. Engineers figure out at the very start of the design process how much weight they need and how much space they should allot for that kind of weight. To wrap this up, we identified another property of material, which is density. Again, we can define it as the ratio of mass per unit volume of substance, or in terms of its atomic structure, how concentrated atoms are in a crystal lattice. We have identified some evidences of density in our everyday life and how professionals apply its concepts on their work. Can you cite other applications of density? If you have, do not hesitate to include it in our discussion board and let us compare the observations of your classmates. Once again, this is Gilmar De Castro and I will see you in the next video.